In a research experiment, a population of fruit flies is growing exponentially. After 2 days, there are 60 flies, and after 4 days, there are 180 flies. How many flies will there be on the 5th day of the experiment? Our population is growing exponentially, which means we are looking for an equation of the form P is equal to CA raised to the T. We know that after 2 days there are 60 flies, so the point 2, 60 must be a solution point to our equation. We know that after 4 days there are 180 flies, so the point 4, 180, must also be a solution point to our equation. So we can find a model for this situation by finding the equation of the exponential curve that passes through the points 260 and 4, 180. We begin by plugging in the points as if they belong. So we get 60 is equal to CA raised to the second, and we get 180 is equal to CA raised to the fourth. We divide the second equation by the first, so 180 divided by 60 is equal to CA raised to the fourth divided by CA raised to the second. 180 divided by 60 gives me 3, and on the right hand side of the equation the C values will cancel out. I will get A raised to the 4 minus 2, or A squared. I take the square root of both sides, and I will get A is equal to 1.732. And you should store this value on your calculator. So far, I have P is equal to C times 1.732 raised to the T. I still need to find my value of C. I will use one of our original equations. So I have 60 is equal to C times 1.732 squared. I will divide using my stored value, and I will get C is equal to 20. So my model is P is equal to 20 times 1.732 raised to the T. If I want to determine how many flies there will be on the 5th day of the experiment, I simply plug in 5. P is equal to 20 times 1.732 raised to the 5th. And again, I will use the value A stored in my calculator to get 311.769 flies.